Notes and examples for section 2.3, linear functions and slope. For this section, we are going to dive very deeply into what a linear function is, how you can graph them, how you can find a linear function given some information. But first, we need to find or to discuss what different types of slope there are in a linear function. So first type of slope we can have in this first graph is a positive slope, and that is an increasing line. We could also have a negative slope. You could also have a zero slope, which you would know is constant. And you could also have an undefined slope, which would be a vertical line. So just to label these, you have positive, negative, zero, or if you like, horizontal, and undefined slope, or vertical lines. And we're going to talk more about these horizontal and vertical lines a little bit later. But right now I want to concentrate on slope, and I want to show you how to compute a slope. You can compute a slope if you know two ordered pairs on a line. One ordered pair being x1, y1, and one ordered pair being x2, y2. So we put this little 1 and 2 down here just to differentiate between the different x values. So one point has two coordinates, an x and a y value, and the other point has two coordinates, an x and a y value. But we really want to make sure that you know that these are two different points. That's what the little numbers do. So then we can use this slope formula. M is what we represent in mathematics as slope. So we're using the slope formula, which is equal to y2 minus y1 over x2 minus x1. And the best thing I can do here is to just jump into a couple of examples so you can see how this works. So over here in example 1, I want to label my 2 points. So I'm going to call this point 2, 1. I'm going to call that point 1. And over here, this 3, 4, I'm going to call this point 2. And you can see that I have an x value and a y value for point 1, and an x value and a y value for point 2. So you can see that this 2 should be x1, and this 1 here should be y1. Those are the x1 and y1. That's the first point. This 3 will be x2, and this 4 will be y2. So what we have to do now that we have these numbers is substitute them back into this formula up here. So I know that the slope will equal y2, which is 4. That's right here, y2, that's this y value. And I'm going to put that in parentheses, and anytime I work through these, I'm going to put parentheses around my substitutions. Y1, that's here, y1, that's this 1 value right here, so 4 minus 1 in the numerator, all over x2 from this formula. X in the second point is right here, that's a 3, a value of 3. So that'll be 3. And the last part of this formula up here is x1. That's the x coordinate in the first point, which is 2. So I'm going to minus 2. So 4 minus 1 in the numerator gives me 3. And 3 minus 2 in the denominator gives me 1. Now a little later on, it's going to make a ton of sense to leave this as a fraction. But if you are only trying to compute a slope, you will want to simplify that to be 3. In example 2 over here, I'm going to do this in red. Again, you are asked to find the slope of a line passing through the pair of given points. So I'm going to call 6 comma negative 4.1 and 4 comma negative 2.2. And then each of these have an x and a y value. So you can see here that 6 is x1, negative 4 is y1, positive 4 is x2, and negative 2 is y2. So with this, you just have to substitute these numbers into the slope formula at the top of the screen here. And you'll get that the slope is equal to y2, which is negative 2, minus y1, which is negative 4, all over x2, which is positive 4, minus x1, which is positive 6. Now the denominator here is pretty easy to compute, where the numerator we're going to have to do just a little bit of simplification. So 4 minus 6 in the denominator here is negative 2. And in the numerator, we have negative 2 minus a negative 4. Well, subtracting a negative is like addition. So we can say negative 2 plus 4, it will give us a positive 2 in the numerator. And then 2 divided by negative 2 is negative 1. So I would suggest pausing the video and trying to find the slope for example 3. I would also say trust yourself through this one. You just substitute these numbers into the formula and you will get an answer. Hopefully you are getting this for your answer. The slope is y2, which is 4, minus y1, which is 3, over x2, which is 2, minus x1, which is negative 1. This creates another subtracting a negative or addition, so you get a slope of 1 over 3. And I want to go over this last example. I'm going to do it in green here. The slope here is y2, which is negative 2, minus y1, which is negative 2, all over x2, which is 4, minus x1, which is 6. So in the top, when you subtract something away from itself, you always end up with a 0. So this will be 0 over negative 2, which is 0 slope. And if you go all the way back up here and take a look, when you have a 0 slope, that means you have a constant line. It's a flat line. So, on to the next page. Finding linear functions given information. There are a couple ways that we can do this depending upon which information you're given or the goal of the exercise. I am a big fan of the point slope form. That's not what I wanted. There we go. Point slope form. I really, really like this point slope form. Some professors really, really like this y-intercept form or slope-intercept form. We will get to both of these individually. Some information for you. We have already talked about m. If you look at both of these equations or all of these equations, we have already talked about m as being the slope. So we already know what that means. Also, in equations, we know that, when we're talking about functions, that there will be two variables, so x and y, like right here, all of these little green underlines, x's and f of x's, remember that's the same thing as y. All of those will appear in all of the equations that you will be writing. What will change is the m as the slope. That will be written as a number. The b we call the y-intercept, or the y-int, short for intercept. That will also be a number. And then the last thing that will also change, or you will substitute numbers in for, are this x1, y1. And we've already talked a little bit about that. That x1, y1 will be an ordered pair, and that will be given to you. So one thing that you want to do is be able to create both forms of these equations given some information. Okay, so we have this first scenario given a point and a slope. So we know that we will be given an ordered pair and a slope. Well, if you know the point and the slope, chances are you will want to use the point slope form. I mean, we name these as they are, so we can use them. So we have a point, we have a slope. Let's use the point slope form. So I'm going to call this negative 4 x1. I'm going to call this negative 2 y1. And the m is already equal to 4. So I'm going to write down the point slope form, and you can either use y or f of x. Either one is fine. I tend to use y for linear functions, so I'm going to write down y equals m times x minus x1 plus y1. So now all I have to do is substitute these numbers in. You look over here, m is 4. So I'm going to write y equals 4 times x, and now we have to substitute some numbers in for this x1 and y1. So before we do that even, I want you to pay close attention to this minus sign. This minus sign will always be here. We may have to simplify it, but we'll see what happens. So x1 is right here. That's going to be negative 4. So I'm going to substitute in that negative 4 for x1 plus y1 over here is negative 2. So there's a negative 2. And so simplifying this like we've done many times before, x minus a negative 4 is the same thing as writing x plus 4. So I'll write this y equals 4 times x plus 4. And then over here, adding a negative number is the same thing as subtracting. So minus 2. So this is what I will abbreviate as P-S, point slope form. Now, if you want to turn this into slope intercept form, you will notice that back up here at the top, that it is y equals mx plus b. Notice there are no parentheses, there's no distribution happening here. It is y equals mx plus b. In order for you to get the slope intercept form, you need to distribute the 4. That is the slope. So that will give us y equals 4x plus 16 minus 2. And then we can combine these two numbers here to give you y equals 4x plus 14. And so this is slope intercept form. Why you need to know slope intercept form is that this form of an equation is much easier to graph, and we will get into that a little bit later. So if we look down at these next couple examples, I want you to try this one, this one on your own, and I'll write the answer up here in a few seconds. Here's the solution for example 2. Hopefully you got that the point slope form, after you substitute in the negative 8, the positive 4, and the negative 1 respectively for the slope, the x-coordinate of the point, and the y-coordinate of the point, you get this point slope form. And then essentially going from point slope to slope intercept form is just distributing this -8 to the x and the -4 to get -8x plus 32 minus 1. Combine these constants to get 31. Example 3, I'm hesitate to do this right now. One way to think of this is that the linear function passes through this point, 3, 0, with an undefined slope. What that means, if you have an undefined slope, if you remember from the first page, that means you have a vertical line. So the undefined slope tells you a vertical line. And what that means is if you have a vertical line, your equation vertical lines have the equation x equals some number. And it's very easy to know what number that is. If you come over here and look at the ordered pair, the x coordinate, since we're looking for x equals some number, the x coordinate is 3. That means the equation of this line will be x equals 3. So similarly, or by a similar example, if I gave you an ordered pair, say 5, 4, and said that the slope is 0, anytime you have the slope is 0, this tells you that you will have a horizontal line. And if you have a horizontal line, that will take the form of y equals a number. And so again, like when we have vertical lines with an undefined slope, that ends up being x equals a number. The x coordinate told us what we needed. So here, since we are looking for y equals a number, we will have y equals, this ordered pair over here has a 4 in the y coordinates. So we will be looking at the equation y equals 4. All right. So down a little further, we have examples 4 and 5. And these examples are just going to seem a little bit harder. And that's because you no longer have a slope, but you have 2 points. Right? So we need to find a linear function that passes through these 2 points. We've got 3, 5 and 8, 15. Well, on the first page, we had a formula to figure out what the slope was, that being the slope formula. Why don't we do that again really quickly? So y equals y2, I'm going to call 15, minus y1, which is 5. That's the y coordinate in the first point, all over x2, which I'm going to call 8, because that is the x coordinate in the second point, minus x1, which is 3, because that is the x coordinate in the first point. And that gives you 10 over 5, which is 2. So now we have a slope. So we had to do a little bit of work to get the slope here, but there it is. And now that we have a slope, we can use the techniques that we had up here in the first 3 examples. We were given a slope and a point here in example 1, so we were able to find a point slope formula and then solve it for y. Solve it completely for y by distributing the slope and combining like terms. So the only difference between being given a slope and a point and down here being given a 2 points is that you have to figure out what the slope is. And we've already practiced that, so I'm going to pause for a few seconds to give you a chance to pause the video. And you try to come up with the equation of this line for example 4, and find the slope and the equation both equations of the line for example 5. So here are the answers for the final two examples on this page. If you look at example 4, we found the slope together. You just have to use the slope in the point slope form in front of all the sets of parentheses. So the 2 is there times x minus, and you may have been wondering, which point do I use in the point slope form? It doesn't matter. You can use either point in the point slope form and you are correct. So one version of the point slope form might look like this: y equals 2 times x minus 3 in parentheses plus 5. If you chose the other point, you would have y equals 2 times x minus 8 in parentheses plus 15 on the outside. The cool thing is whichever point you used, when you distribute the slope, the 2 times the x and the 2 times the negative 3 gives you the negative 6. And when you combine the terms over here, you will get the same slope-intercept form every time. So here's your slope-intercept form. With this one, the point slope form is here, negative 4/3 times x plus 3 plus 6 outside parentheses. The slope, when you compute it, ends up being negative 4/3. Fractions happen, don't let it scare you. Then over here, when you distribute the negative 4/3 to this 3, you can use the calculator to multiply those together if you like. That will give you a negative 4. That's where this negative 4 comes from. Then you can combine these two numbers to get positive 2. Another skill you will need for this section is to solve for y, and even past that you will need to graph the line. So when you're solving for y, you want to think of this as a literal equation, but it's not only variables or very small, sparingly used numbers. So the first step that you'll always want to do when you're solving for y is move the x's. And that will always either be by addition or subtraction, depending upon what the sign is. So in this first example, you will want to subtract 3x from both sides. And what that will do is that will give you a new equation that looks like y equals negative 3x minus 5. And you may notice that this is in slope-intercept form. Here we can pick this out. We can say y equals mx plus b. So there, we solved that one for y. I want to solve example 2 for y just to give you another example of how this works. Now, if you look at number 2, we have the 6x and the negative 20 on the same side as the y. So remember, when we were solving linear equations, the first step was to get rid of any terms by addition and subtraction. So you may have to modify step 1 to say move x's and constants. And again, this will be done by addition and subtraction. So this will end up being subtract 6x and add 20 to both sides. So you'll end up with an equation that looks like this. The second step then is to divide by the y coefficient. So when you're dividing by the y coefficient, that is this number, and I'm going to write this step all the way out. So divide by negative 5, divide by negative 5, divide by negative 5. And look here, just like in the last page, when you divide negative 5 by negative 5, you'll get the y equals negative 6 divided by negative 5 is 6/5x minus 4. You get the minus 4 from the 20 divided by negative 5. So we have another rational slope or fraction for a slope. That happens. Please do not let that scare you. And I actually want to graph example 2 before we go back and graph example 1. So some more about this slope intercept form, this y equals mx plus b. The number all by itself, this negative 4 or this negative 5, that tells you the starting point. And that starting point, we're going to mark it on the y-axis. We call this the slope intercept form. And when we're finding an intercept, that is where does it cross an axis. So we have to label it as a y-intercept or an x-intercept. And in this case, the constant, just the number, is the y-intercept. So we're going to find this number negative 4 on the y-axis, which is right here, and I'm going to plot a point. From there, I will use the slope and it's going to be like a little game. My first point is right here on the graph. Where's my next point? Well, the slope will tell you where the next point should be. So there are a couple things that can happen, and in this scenario, in example 2, we have a slope of 6 over 5. And I love it. You will love it when the slope is a fraction. So that tells us that from the point on the y-axis, we need to go up because the 6 is positive, and we will go up 6 units from this point right here. So we'll count up 6 units. And then after we count up 6 units, we will go to the right 5 units. So the denominator always tells me go right, go right, go right, go right. The numerator will tell me either go up or go down, depending upon if it's positive or negative. So I'm going to count here. I'm starting from my negative 4. I'm going to go up 6, so 1, 2, 3, 4, 5, 6. Then I'm going to go to the right 5. 1, 2, 3, 4, 5. And technically, you only need 2 points to draw a line. So I'm going to draw a line as best I can. There we go. So we have those 2 points. Now if we come back here and look at example 1, a couple things. You'll notice that the slope here is not a fraction. Well, that's all right. You can always turn any number into a fraction if you put it over 1. The next thing you may notice is that the slope is negative. Right here, this negative 3. Over here it was positive 6 over 5. Over here it's negative 3 over 1. So if you have a negative slope, you always want to put the negative in the top. So this 3, this negative 3 in the slope tells me I want to go down 3, and then the denominator, this 1, tells me I want to go right 1. But before we do any of that movement, we first have to plot this value. This is the y-intercept, this negative 5. This is not the last time we will deal with this y-intercept idea. You will see it very soon. So I know I've got to come down here to negative 5 and put my point. And then now, to get to my next point on this graph, because I have no idea where it's supposed to be, I'm going to use the slope. Starting at the y-intercept, I'm going to go down 3, 1, 2, 3, because that's what the top number tells me, down 3 because it's negative, and then right 1. So there's my second point. And in this case, my graphing skills are not good enough to make sure that line looks good. So how would I get some points to go in this direction? Because I know it looks like from this point to this point, left to right, it looks like it's going to be a decreasing line. How would I know that, or where the points over here are supposed to go? Well, you can reverse the process completely. So to get from my starting point to this point, I had to go down 3 and right 1. Well, if I reverse that process and I go up 3, 1, 2, 3, and left 1. Okay, there I've got another point. So I can go exactly the opposite. And since we are graphing lines, it looks like these 3 points are all form a straight line. So let me draw a couple more points in here. So up 3, right 1, left 1. Up 3, left 1. There, that gives me a better idea on how I should graph this. So I'm going to try to graph this as best I can. And there's my line. All right, let's look at a couple other examples here. So you'll see with example 3 and 4, so example 3, y is not completely solved for, so we will have to solve for y. And then it'll look like, we'll do that by adding 3 to both sides. So add 3. And that looks like we will have some sort of equation like y equals negative 2x minus 3 plus 3. Now this looks like a point slope equation. And I mentioned in the last page that it's going to be much easier if you turn this into slope-intercept form. So pause the video, take a few seconds, and practice turning this equation into slope-intercept form. When you turn this into slope-intercept form, you should get y equals negative 2 times x plus 9. So what that looks like down here on the graph, we know that the starting point on the y-axis will be 9. So I'm going to put that point there. And that the slope is a negative 2, but it'll be much, much easier if you turn this into a fraction that we know. That way we know how far to move up or down with the numerator and how far to move to the right with the denominator. And again, since this number in the numerator is negative, we will end up moving down 2 units and right 1 unit. So now we get to start at the y-intercept, go down 2 units and right 1 unit, down 2 units and right 1 unit, and we can continue the pattern like so. And with the pattern continued, you can see we can go down 2, right 1, down 2, right 1, down 2, right 1, and then we can make this line. For example 4, you can see that this equation, this function, is already in point-slope form. To convert this over into slope-intercept form, the equation will then look like this. The slope is 1/2, and it's already a fraction, so that's nice for us when we get over here to graphing. And the y-intercept is negative 1. So we're going to start over here at negative 1. That's what the constant up here tells you to do. This is the starting point on the y-axis. And then the slope, the top number tells you how far up or down you're going to go, and the bottom number again always tells you how far right you're going to move. So this tells me, since it's a positive 1, I'm going to go up 1 unit and then right 2 units. Up 1, right 2. So down here I'm going to go up 1, right 2, plot a point, up 1, right 2, plot a point, up 1, right 2, plot a point. And just to go in the opposite direction, I'm going to go down 1, left 2, plot a point. And you can see that while I follow this pattern of down 1, left 2, that all of these points look like they are on the same line. So there is the graph of this last equation in example 4. We mentioned earlier that there are 4 differently sloped lines, and we've seen some negatively and positively sloped lines in the last page. Let's concentrate a little bit on the 0 sloped lines and the undefined slope lines. One thing I hope you'll notice is that in these examples, each function only has one variable. And we mentioned a little bit about that on a previous page. But in order to graph these linear functions, the first thing you need to do is solve for the variable and then graph the line accordingly. So in this example 1, if you subtract 18 from both sides, you'll get 3x equals negative 18. And then when you divide by 3, that gives you x equals negative 6. So this last statement, x equals negative 6, is very telling. So that tells you what axis you're going to go to. So we're going to go on the x-axis to the number negative 6. So that's right here. You need to put a point right there. And since this is x equals some number, that will give you a vertical line. So we will go up from there and down from there. And that's it. That's graphing x equals negative 6. In this second example, you'll see that f of x equals negative 2. Well, this is the same thing as saying y equals negative 2. And any time you have y equals a number, you'll end up with a horizontal line. And so again, once you get a final answer, final simplified version with one variable, the variable tells you which axis to go to. So we're going to go to the y-axis, and we're going to go all the way down to negative 2 on the y-axis, which is right here. And since we have y equals a number, this will be a horizontal line. All right, let's go on to the last two examples here on this page. We have x equals 3, or x plus 3 equals 10. And I don't even want to get into the steps to solve this. X equals 7. So it tells us which axis to go to and what number we're looking for on that axis. X-axis, number 7, that's over here. And x equals a number will be a vertical line. In this last example, I have this 3y minus 11 equals negative 2. So add 11 to both sides, that will get you 3y equals 9. And then divide by 3, that will get you y equals 3. So this tells you, again, one variable in your linear equation, linear function, tells you which axis to go to. So we're going to go to the y-axis at the value positive 3. So right here. And y equals a number gives you a horizontal line. And these last two pages are your practice, so get working. Good luck.